This is the notes video for section 1.5, slides 28 and 29. All right, so once again, this says give the equations of all asymptotes. All right, so remember, we need to think about vertical and horizontal, right? So when we think about vertical asymptotes, we first of all want to look at the denominator, right? So we want to look at when is the denominator equal to 0, all right? So first thing I'm going to do is I'm going to set the denominator equal to 0, but I'm going to factor out uh, a 2. So x squared plus 3x minus 4, all right? And I'm going to set it equal to 0. I can divide by 2, and then I can factor the quadratic. All right, so this one would factor into x plus 4, x minus 1, right? Which means that x equals -4 or +1, right? So now what does that mean? That means that -4 or +1 are potentially vertical asymptotes. We can't just say that they are vertical asymptotes because remember, we need to evaluate the limit as x approaches -4 and the limit as x approaches 1. All right, so what we're going to do is we're going to evaluate the limit as x approaches -4 of f of x, right? F of x is given to us up there, right? So now, if we evaluate the limit as x approaches -4 of f of x, what do we get? Well, we know we get 0 in the denominator, right? Because we just figured that out, right? But what about the numerator, right? So if I have -4 cubed minus 2 times -4 squared minus 3 times -4, right? We need to determine what that value is, right? So -4 cubed is -4 times -4 times -4, -64 minus -4 squared, right? 16 times 2, so minus 32, and then plus 12, right? So sometimes when I'm doing something like this, I'm trying to think like, all right, do I need to do all this work? Well, no, because -64 minus 32 gives us -96. Okay, this isn't 0, right? So like, I don't even want to do the work, but I just know that it's not 0. So what does that mean? Non-zero over 0 is going to tell us what? Well, it's going to tell us that there is a vertical asymptote there, right? Because remember, if it was 0 over 0, then what would that tell us? That would tell us that x plus 4 would actually have to reduce, right? And so now I'm going to evaluate, all right, what happens as I approach limit as x approaches -4 of f of x, but now from the left, and then the limit as x approaches -4 from the right. All right, and this is when we're trying to determine the nature of the graph. All right, so if I do that, what do I get? Well, in the numerator, if I'm approaching -4 from the left or from the right, I'm still approaching a negative number, right? So I'm just going to put a negative number, right? So actually, right, -96 plus 12 would give us -84, right? So it's a negative number, right? And that's really all I care about. All right, but then in the denominator, yes, I'm approaching 0, but what am I approaching 0 from? From the left or from the right? From the negative or from the positive, right? So if I think about it, if I take, right? So I would say like negative or positive, right? And this is what we're asking ourselves. So if I take -4 from the left plus 4, and then I take -4 from the left minus 1, what am I ending up with? Well, -4 minus 1 is -5, right? So that's going to be a negative number, right? But then -4 from the left plus 4. What's a number to the left of -4? How about -5? -5 plus 4 is a negative. So I'm going to have a negative number times a negative number. So what does that mean? That means I'm approaching -84 over 0, but from a positive, right? Remember, we got a negative number times a negative number. And so I have -84 over a positive number. And so that's going to be approaching -infinity, right? So what does the result of getting that this limit is equal to -infinity tell us? It tells us that there is, in fact, a vertical asymptote at x equals -4. All right, now we also want to evaluate from the right. All right, so we're going to go through the same process, but in the numerator, we're still approaching -4. It doesn't matter if we're approaching -84 from the left or from the right. It's still a negative number, right? Like -83 or -85 on either side of -84 are going to be a negative number, right? All right, so now in the denominator, now -4 from the right plus 4 times -4 from the right minus 1. All right, -4 from the right plus 4. So what's a number to the right of -4? How about -3? -3 plus 4, right? Remember, that would be a positive number times -4 minus 1, that would be -5. So a positive number times a negative number. So that means I get a -84 divided by 0, but from the negatives, right? Positive number times a negative number is a negative number. And so I have a negative over a negative gives me a positive infinity, right? So once again, that is another verification that there is, in fact, a vertical asymptote at x equals -4. So we'll write that in just a moment. But now, what about the limit as x approaches 1, right? From up here, limit as x approaches 1. So remember, limit as x approaches 1 of f of x. So we want to evaluate, right? So now if I put positive 1 into the numerator, I get 1 cubed minus 2 times 1 squared minus 3 times 1, right? All divided by, well, remember, I put 1 into the denominator, I'm going to get 0, right? All right, so 1 cubed is 1 minus 2 minus 3 over 0. So 1 minus 2, -1 minus 3 is -5, right? Sorry, -4. I apologize. -4 over 0. So once again, we're in the same situation that we were with -4, right? And so now we want to examine the limit as x approaches 1, but from the left, and then the limit as x approaches 1, but from the right. All right, limit as x approaches 1 from the right of f of x. All right, and so now I have, once again, the numerator is going to be -4, right? I'm approaching that no matter what. All right, denominator. All right, so once again, if I take the uh, 1 from the left plus 4, and then 1 from the left minus 1. All right, so I have -4 over. All right, 1 from the left plus 4, that's a positive number, right? That's +5. 1 from the left minus 1. What's a number to the left of 1? How about 0? 0 minus 1 is negative. So now I have a positive number times a negative number, so that's going to be a negative number. So I'm approaching 0 from the negative, so negative over negative is positive infinity, right? All right. Next, I have -4, but now -4 in the numerator. Now I'm approaching 1 from the right. So 1 from the right plus 4 over, or sorry, times 1 from the right minus 1. All right, so numerator always approaching -4. Doesn't matter if it's from the left or the right because those are negative numbers. All right, so now 1 plus 4, obviously a positive once again. All right, 1 minus 1, right? Well, that's 0, but 1 from the right. What's a number to the right of 1? How about 2? 2 minus 1 is a positive. So I have a positive number times a positive number, so I get 0 from the positives. So now I have a negative divided by a positive, which means I'm approaching negative infinity, right? So what does this result tell us? It tells us that there are vertical asymptotes at x equals, what is it, -4 and +1, right? Remember, why is that? Because the limit as x approaches -4 from the left and or from the right is approaching negative infinity or positive infinity, right? And the same thing is true with x equals 1. All right, so now what about horizontal asymptotes, right? So remember, horizontal asymptotes, we are examining the limit as x approaches infinity, right? And if the limit as x approaches infinity gives us a number, then that means we are approaching a horizontal asymptote, right? Or if we say the limit as x approaches negative infinity. All right, so let's start with limit as x approaches positive infinity. All right, so we need to look at the function x cubed minus 2x squared minus 3x. All right, so we are going to evaluate the limit as x approaches infinity of f of x, right? And so that means we are taking infinity cubed minus 2 times infinity squared minus 3 times infinity, right, over 2 times infinity squared plus 6 times infinity minus 8. All right, so sorry about that. I just couldn't see that other part. All right, so now, well, of course, infinity cubed is infinity minus 2 times infinity squared. Now, sometimes people say, oh, infinity minus infinity. Well, no, that's not 0. Remember, infinity cubed is infinitely larger than this, right? So the numerator ends up being positive infinity divided by same thing in the denominator, positive infinity, right? And so we get infinity over infinity, which is also an indeterminate form. And so that means we have more work to do, right? So remember, how do we evaluate this limit as x approaches infinity? We're going to divide everything by the highest power of x, right? So x cubed is the highest power. So I'm going to take x cubed divided by x cubed minus 2x squared divided by x cubed minus 3x over x cubed. And then in the denominator, 2x squared over x cubed plus 6x over x cubed minus 8 over x cubed. And then we're going to reduce. So limit as x approaches infinity. All right, so limit as x approaches infinity, we get 1 minus 2 over x minus 3 over x squared, all divided by 2 over x plus 6 over x squared minus 8 over x cubed, right? So now we reevaluate. We get 1 minus 2 over infinity, which is going to be 0, minus 3 over infinity, which is going to be 0, 3 over infinity squared, which is going to be 0, and 2 over infinity plus 6 over infinity squared minus 8 over infinity cubed, right? So really, what do we get? We get 1 minus 0 is 1 over 2 over infinity, 0 plus 0 minus 0. So we get 0. So 1 over 0 is going to be what? Well, we're approaching an infinite value. This is not a finite value. This is not a number. And so that means that there is no horizontal asymptote. Now, you may also recall from pre-calc, right? If you were to look at this, right? You would look at this and say, oh, well, the degree of the numerator is greater than the degree of the denominator. And so there is no horizontal asymptote, right? All right, so that is example 3. I know that was kind of a long one. All right. If at any point when you're watching these, you need to take a break, that's fine. All right, so now let's take a look at this one. All right, so first step would be to set the denominator equal to 0. X squared minus 9 equals 0. So I factor x plus 3, x minus 3. And so I get that x equals negative 3 or positive 3, right? All right, so that means I want to evaluate the limit as x approaches, well, let's start with 3 of f of x. All right, so I'm going to do that. I get 3 squared plus 2 times 3 minus 15 divided by 3 squared minus 9. Of course, we know that the denominator is going to be 0 because we already did that work. But what about the top? 3 squared is 9 plus 6 minus 15. 9 plus 6 is 15. Minus 15 is 0. So 0 over 0 tells you what? It doesn't tell you anything other than that you have more work to do. So now we're going to do that work. So the limit as x approaches 3, and now I want to factor, right? So I can factor the numerator into x plus 5 times x minus 3, right? And the denominator factors into x plus 3 times x minus 3. And so x minus 3 reduces, and then we reevaluate. So we get 3 plus 5 divided by 3 plus 3. And so I get 8 divided by 6, or 4/3. So what does that mean? Remember, 4/3 is a number, right? It is not 0 over 0 or infinity over infinity, right? So that means what? That means that the limit exists. Therefore, there could not be a vertical asymptote there, right? Remember, what does this result tell us? That if we're looking at a graph, right, as we approach 3, there must be a line coming in from one side and a line coming in from the other side, and we have a closed or an open circle. Why is it an open circle? Because initially we got 0 over 0, which is undefined, right? So that means there's no vertical asymptote at x equals 3, right? So what about the limit as x approaches negative 3? Well, you can do yourself a favor. You've already reduced this, right? So we know that this function only behaves differently at x equals around x equals 3, but at x equals negative 3, it's just going to behave like what this x plus 5 over x plus 3 is. So x plus 5, right? So negative 3 plus 5 is 2, divided by negative 3 plus 3 is 0. So 2 over 0, right? So what does that mean? That means that there is a vertical asymptote there. So now what we need to show is that the limit as x approaches negative 3 from the left, so x plus 5 over x plus 3. All right, so now, once again, I'm approaching 2 in the numerator, right? But now in the denominator, if I have negative 3 from the left plus 3, what's a number to the left of negative 3? How about negative 4? Negative 4 plus 3 is a negative number. So 2 over 0 from the left means positive over a negative is going to approach negative infinity, right? And then we can say the limit as x approaches negative 3 from the right of x plus 5 over x plus 3. And so once again, I get 2 over negative 3 from the right plus 3. So what's a number to the right of negative 3? How about negative 2? Negative 2 plus 3 right, is of course going to be a positive number. So 0 from the positives. And so I have a positive divided by a positive, which means I'm approaching positive infinity. And so what does this result tell me? That there is a vertical asymptote at x equals -3, right? Okay, so now we want to examine the existence of a uh, horizontal asymptote. Now, do yourself a favor. Think back to what you should already know from pre-calc. You should know that the degrees are the same, and so what does that mean? That means that the degree of the numerator and the degree of the denominator are equal, and so the horizontal asymptote is going to be the leading coefficient of the numerator divided by the leading coefficient of the denominator. But what do we need to show as far as calculus is concerned? We need to show that the limit as x approaches infinity of this function f of x is in fact a number, right? So we need to show that work, right? So when we initially plug in, right, we get infinity squared plus 2 times infinity minus 15 divided by infinity squared minus 9. Of course, this is going to result with infinity over infinity. And so then we want to divide everything by the highest power of x, right? And so we do that, and we get what? We get x squared, that's squared, x squared over x squared plus 2x over x squared minus 15 over x squared divided by x squared over x squared minus 9 over x squared. All right, so remember, x squared over x squared is 1. So limit as x approaches infinity of 1 plus 2 over x minus 15 over x squared, nothing to reduce there, divided by 1 minus 9 over x squared. So now I reevaluate with infinity. All right, and so I get 1 plus 2 over infinity minus 15 over infinity squared divided by 1 minus 9 over infinity squared. All right, and so what does that mean? 2 over infinity is 0, minus 15 over infinity squared is 0, so I get 1 over 1, which is 1, right? Which is what we already had expected. And so what would you say? There is a horizontal asymptote at y equals 1. Remember, you have to say x equals for vertical, y equals for horizontal. All right, so that is slide 28. All right, so let's move on to slide 29. All right, now, so this is an interesting one. It says sketch a graph of this, right? So what does that mean? Well, we need to think about what this information is actually telling us, right? What do we know about this, right? So the limit as x approaches infinity of f of x is 3. So remember, x approaches infinity means we're going to the right, right? And if it's a number, that means as we go to the right, our curve gets closer and closer and closer to 3, to y equals 3. So if I go here and I put y equals 3, that means as we go to the right, we're either coming up towards y equals 3 or we're coming down towards y equals 3. So that's talking about the existence of a horizontal asymptote. All right. What about the limit as x approaches negative infinity? Now, remember, that means we're going to the left. So that means we're going this way towards 3 or this way towards 3, right? Now, remember, it's one of these two on the right and one of these two on the left. It can't be both, right? But it can be like this one here and this one here, right? Or the top two or the bottom two or whatever, right? Remember, it can't be both of these because then this thing would fail the vertical line test and it wouldn't be a function, right? So that is not the case, right? So we need to make sure we remember that. All right, so now we know what's going on there. So now let's think about what this tells us. The limit as x approaches -1 from the left is positive infinity. All right, so -1 would be here, right? That's a vertical asymptote, right? So that means we're either approaching, not either, we are approaching this way and going upwards, right? That's the only way that it could turn out, right? And then the limit as x approaches -1 from the right is negative infinity. So the only way that that can turn out is going this way. All right, so now what could the graph look like? Well, we have our horizontal asymptote of y equals 3 and our vertical asymptote of y equals -1. And so we could have a graph that looks like this, right? Approaching 3 from above on the left and approaching -1 here, and then we could be going like this, right? This is a possible sketch of what this function f of x could look